Welcome to today's episode of Almost Human. Today we'll be talking about meta learning. It's the way to teach AI how to learn. So instead of needing millions and millions of CT images or cyber history of the entire domain, you can actually teach the AI model from an adjacent distribution how to best use limited amounts of data. It's an equalizer for early stage startups that don't need $100 million in order to train a new foundation model. Today, I'm joined with Liran Tam, and who I actually know before AI was really considered AI, right? It was 14 years back. Almost 20, that is incredible. So you build guitars, right? But the physics engine behind guitars with machine learning. And then in simply at the time it was called Joy Tunes, built the engine, the recognition engine. You've done robotics, you've done almost anything and everything when it comes to new data sets and new machine learning approaches. We're not targeting AI academics. The people we're targeting are founders, entrepreneurs. The goal is for them to walk away when they understand what meta learning is. They're not panicked about it, and we'll just focus how it changes the game for early stage founders. If you had to summarize what meta learning is in 20,000 feet, like what is it?
So maybe before that, we as humans has this incredible ability to generalize and to adapt to new tasks very quickly, very efficiently, right? It's from really early stage of development. We can pick up new skills. With just a few examples, we can pick up patterns and generalize. And this is a really inherent or fundamental trait in intelligent behavior, really, right? So we don't exhibit that behavior usually with even large foundation models, right? They don't adapt efficiently to new tasks, right? Take ChatGPT, for example. You can teach it new trick, right? It's called inference or in-context learning, or you can fine-tune it to some out-of-domain or some similar distribution. But generally, it won't generalize as good as humans, especially not with just few examples. That's the general case.
Yeah.
So to the rescue, meta learning, right? So meta learning is about training models to learn how to adapt quickly to new tasks. That's the premise. Often with very little data. More precisely, it's to very efficiently. It could be the adaptation phase, the tuning phase will only have just a few gradient backpropagation steps or a handful of examples. So that's, I think, with broad brush strokes, that's meta learning.
So if I look, and one example that many people use is oncology, right? It's like if you look at fine tuning or even the pre-training, a lot of it is just memorization and then building abstractions. But if I, as a startup, have 42 images and Google has 2 million, like what chance do I have? And so how is this example a good example of meta learning? And if so, like how does it work? Like how do I teach it without needing the 2 million data set?
Well, so first of all, there are no free meals, right? So if you have labeled training data, large labeled training data for your downstream task, then probably nothing beats the supervised learning or semi-soc supervised learning setting. Let's say you have 42 labeled examples of X-ray images of some rare and new medical condition, right? That's the setting. No matter how hard you work, that's all the training data that you can curate, right? So with meta learning, in order to do something with that, to train a model with that, you need to attach it to a larger data set that has similar distribution or draws from the similar domain that is easier for you to have access to, right? So let's say that medical condition A is rare and unique, and only 42 images of X-ray images are available, labeled X-ray images are available. Then what you can do is tap into some other couple of hundred similar tasks, let's say classification tasks of other medical condition, not the rare one, and then train the model not to excel on a specific medical condition, classifying medical condition A, let's say, but to understand the distribution of the tasks themselves, right? So once you do that, you have a pre-learned meta learner, and then you can tune it uh, with your few examples to your downstream task. That's one use case. And meta learning excels, it really shines in that use case. Another use case may be when you have a limited compute budget, right? Either in the training phase or especially in the test phase, in the inference phase after deployment, right? So let's say, for example, you want to do a recommendation system that is personalized per user. Could be for medical, it could be for, I don't know, streaming services, could be like what LinkedIn did for recommending job opportunities, paper that they published, I think in 2024, I want to say. So the best candidate that will give you uh, best shot of solving that problem would be meta learning, where you have just a few examples on a large set of users. So each user will be considered a different task, right? And instead of training a huge model that try to pick up all the latent abstractions and all the representation of the data on top of all the users, you can keep the model really tight and really mean. In terms of compute capacity, it only needs to have the capacity to do well on a specific user, right? That's between 1 and 2 orders of magnitude less than what you need when you train a large foundation model, right? And you train that model in under the meta learning paradigm to do well not on that specific user, but to do well at the tuning phase, right? So,
All right.
right.
So
So that's the premise of that's the general idea, I think.
so I love this. So first, if I zoom out to the business side, so markets too small for there to be data collected, or markets too backwards for there to have collected information at all, right? And then the question becomes is what if you look at that kind of adjacent data set that you can actually train on, like how close does it need to be? Like the teacher data set to the student data set? Like what actually could work? Because I won't take irrelevant information. It won't help me of actually creating that easier to learn with a smaller data. So how close does it need to be?
Well, that's one of the pitfalls of meta learning in general. So, how do you define the domain of the task? Because what you really want to do is train the model on the domain of the task that you want to tune or adapt the model before deployment, right? So, I can give you extreme examples of of things that works. That's not the general case. So, there are some really successful works that show how you at test time you meta trained on video sequences of people doing different tasks, and then at the meta test or when you tune the model, you tune it to a robotic arm that does things on a real environment, right? So we're talking about two very different domains. The overarching arching behavior is the same, right? Some uh, some mechanical thing, a human body or robotic arms, is behaving in some way or another in an environment. So that's a success story. I'm talking about a deployable model in the industry, right? So there are quite a few success story of uh, people that are companies that train the model to do well meta training phase on a fictitious or irrelevant environments or not too similar environments with not even robots, and then tune it every week or so to do some new task on the assembly line, right? So that's one extreme use case or scenario. Another more straightforward scenario is we're talking about the same domain, right? If we're talking about our example with the X-ray, then it's really intuitive. What's the domain? The domain is a classification of medical conditions. They can be very different, the different diseases or whatever, but they should talk the same language, right? They draw from the same input distribution data. It's X-ray images. They could draw from similar imagery, medical imagery like CT scans, but there are set of papers that prove that it doesn't even have to be the same organ, the same part of human body, right? And it works very well.
Is there an opportunity, or maybe is there already a database of domain-based models? Because effectively, what you're saying is, hey, I can actually teach the model to know X-ray, so I can teach the model to understand space and time, right, for robotics, and I'll teach it via video. So, is there an opportunity, or are the meta learning based models just too different um, between themselves or between each other? It goes back to the question of like how close does the base model or the pre meta learning need to be?
So there's this found popularity, sorry, of meta learning in the research community to utilize meta learning as one of the bedrock or really foundation of abstracted thinking and reasoning and generalization problem solving, because the meta learning paradigm enables you to really generalize meta features, right? So if we'll jump few years to the future, then I believe meta learning will play a significant role in something similar to a foundation model that excels in adapting to any kind of scenario or environment or task, stuff like that. But we're not there yet, right? So if you train a meta learner on, let's say, the specific modality audio to, let's say, speech recognition, you have this highly impaired speech with the electoral component, meaning to say a very private speech, either by phonetic or semantic criteria to specific user, and you train a meta learner to specialize in learning a specific user, this will not transfer to, let's say, a robotic arm that do something, some behavior in an industrial setting. It will not transfer. Having said that, there are quite a lot of research work that prove that in a really broad domain like robotics or on a modality of images or videos or audio, whatever audio means, like speech or music or sound production things. So then transfer learning, especially in the setting of reinforcement learning, transfer meta knowledge and meta skills very well across subdomains. So I'm not
So
sure that I answered your question, but
no, it totally did. I think that there's definitely an opportunity, at least in kind of in specific domains, and then creating a database that just jump starts and effectively allows you to validate that meta learning would be good, a good tool for a specific, but then maybe you would start a model fresh after you know that it's interesting. But we'll talk about this in a second. What what you raise also the speed of adoption to customer use cases, right? So Israel obviously being a cyber country and cyber attacks, like every technique is different than another. It's the same domain, but when people do zero-day exploit, it usually is a very different area or different methodology of how they attack. So how is it? is indeed meta learning interesting in adopting within that domain to do just different workflows of a specific attack if I look at cyber?
So I think that, again, it's only my intuition, but uh, when I consider papers that deals with that domain, I think there's a huge opportunity for meta learning in the cyberspace, cybersecurity space, because uh, a lot of the although the environment changed, let's say a network, a specific network topology of company A versus a large scale topology of company B with all these tiers of layers of of networking, a large set of how people attack this network or these services has to do with how we as human think and operate, right? So there are a lot of shared patterns that are assembled or Lego together to create a new virus or new whatever attack against that network. So meta learning, I think meta learning could really excel at that because uh, one of the problems is you learn something at a specific topology or network, right? You learn a specific attack, and then you're having a hard time to apply it in a large scale network or in specific domain network, right? So, or for specific API based service. So meta learning can generalize the underlying features that or patterns that build that specific attack.
That's
So
so
there's a lot of work being done in the academy on that. I don't know specific startups that utilize meta learning in that domain, but it's a shame, really.
no, it's again, and this is the goal of almost human, right? It's like there's so much technology development that is applicable to business problems, but most of the mapping is in people's minds, in researchers' minds versus the entrepreneur. So if I go back to first principles, right? So common wisdom today is that data and distribution are the moats in the AI era. Is effectively what you're saying is that meta learning is pushes that much more towards distribution because you need less data in order to tackle a specific AI problem.
It's an excellent conclusion. I think meta learning shifts the mode from who's having the largest and I don't know uh, raw data sets to who's having the most diverse data set, right? So you don't need to have large number of examples from a specific domain. It's better if you have a small number of examples that already explain or present a domain, right? But a large number of domains. I think that the moat will be shifted, not eliminated. That's one thing to say about the moat. Another thing is there are a lot of things, a lot of opportunities that are overlooked because you don't have enough data to solve them, right? So suddenly, if you utilize meta learning paradigm, then that gives you a potential solution to something that doesn't have enough data.
So I'm sold. Fine. So, but I'm an entrepreneur. I want to figure out whether meta learning is the right approach to the problem I want to tackle. Like, how do I validate that's an interesting problem or that is a relevant problem? Like, what's the fastest way if I'm not a machine learning person?
If you can find similar tasks to your problem that acts or behave in the functional layer, not at the feature layer, not at the specific pixel layer level. If you can find similar tasks to your domain and you have uh, only a fraction of what is needed to utilize the canonical or the traditional supervised learning or semi-supervised learning paradigm, then what you can do is experiment very fast with some open source code. There are quite a few frameworks that implemented the main or even the SOTA, this the state of the art algorithm meta learning, and experiment really fast. I'm talking days, right? Not weeks or months, because it doesn't it doesn't necessitate a radical shift in what you are used to do, right? You just need to assemble training data and apply the model. It's a really little bit more involved in that, but you can experiment very fast on your data and your problem with meta learning, and just see if the problem sticks, if it solves the problem.
So the flip side of that same question is like, what pitfalls should entrepreneur expect when they do meta learning? Like, what's the failure models that you see there is it most commonly?
Unfortunately, there are quite a few. So since meta learning works by applying, I'll say, several time scale resolution of optimizing your target. There's this inner loop and outer loop. There are quite a few parameters that you need to, or meta parameters, pun intended, that you need to determine in order to make the thing work, right? So it's more complicated. It's more involved than just playing with the learning rate and maybe a couple of parameters in your optimizer. So that's one pitfall. Another pitfall would be it's harder to evaluate or to debug what is happening when stuff doesn't work, right? With any deep learning mechanism, stuff doesn't just work from the get-go. You need to optimize your meta parameters and to do some experimentation. So with meta learning, it's really a more involved process. I want to say more, but not much more involved, because it's feasible.
It's mostly being able to quickly understand, like, is there value?
Yeah,
Right? And it could be that there's still 20-30% improvement, but this is applicable. This is workable.
yeah, yeah. That's maybe the main pitfall,
Yeah.
right?
Yeah. Well, a few quick questions. This is awesome. A few quick questions. Like, um, three.
Right.
What's AGI for you? Like, what do you define as AGI?
Oh wow, AGI. For me, AGI is when an agent, it doesn't have to be embodied in a robot, right? An agent would be able to do well, to perform well on most of what the average person can do, right? I think the pinnacle would be if the average researcher, like in the scientific domain, can be replaced with an agent, with a trained agent, we've reached AGI. That's
Right.
right.
When is that? What is that definition? Like, when do you think? If you had
Ooh,
to bet.
April, 2 o'clock, Monday. No, I'm kidding. Within 10 years. I'm not sure that there'll be AGI phase, right? We might
Just
pass
jump to
over
super
that
intelligence. But
straight to A side,
yeah,
right?
that's very short.
And I think
Wait, so
it's
you're playing it
within a
safe.
decade, within our lifetime. Yep.
You're playing it safe. US or China?
Years, definitely years.
Yeah.
I think China is in that regard is a little bit paper tiger.
Oh,
There are
wow.
a lot of research that they produce, but I don't think it's as cutting edge and established as what what the West produces, or at least is on par. US,
So
definitely US.
it's the second episode so far. One China, one US. We'll need to do a tie break at some point. And this is awesome.
I know that you're a strong believer that China would be. It might be
Yeah.
easier. I don't know.
Yeah, no, it's there's an energy problem. Like, China is just much better than the US in pushing energy through. So even at the most basic level, I think US is screwed.
Yeah.
But yeah, anyways, this is awesome. Toda rabah.
Thank you.
What I love about meta learning is that it levels the field. It's not about who has the most data anymore. It's about who adapts fastest. If you're building an early stage company, that's your wedge. You don't need to beat Google at scale. You just need to learn faster in the places they overlook. That's the kind of thinking we'll keep exploring here on Almost Human, where founders, not giants, redefine what's possible. If you have any questions, comments, recommendations for future guests, feel free to email us at almosthuman Aleph.vc. Who knows? We may use your feedback, send you merch, or give you a shout out on the show. If this episode cut through some of the noise for you, share it with a friend or a colleague who's building an AI, and make sure you follow Almost Human so you don't miss what's coming next. I'm Eden Shochat. Thanks for listening. We'll see you next time.